Hi and welcome everyone to this Electri-Flex company webinar. My name is Rich and I'm a senior manager with IEEE Global Spec. Okay, at this time I'd like to introduce to you today's presenters. Gregory Raptors joined Electri-Flex in May of 2013 as Managing Director International and is responsible for driving Electri-Flex's business expansion into the international markets. Now, before coming to Electri-Flex, Greg had accumulated more than 30 years in the industry, including executive positions with Essex Wire, Zero Wire, and Animet Electrical. Greg holds a master's degree from the University of St. Francis in Business Administration with an emphasis in international and a business administration degree from Indiana Wesleyan University. Now also joining us today is Daniel Coolidge. Daniel began at Electri-Flex 40 years ago. He started in tooling, machinery design, and drafting, and then moving his way up the engineering ladder to where he sits today. Dan currently oversees product design and development, standards, and compliance. He also sits on the Technical Standards Committee for NEMA and CSA. Greg and Daniel, welcome to today's event. And with that, I'll pass things along to Greg to get started. Greg, go right ahead.
Thanks for the introduction, Rich. We're excited to share our line of flexible electrical conduits for specialty applications. Since we're limited on time, we'll answer all questions at the end of the presentation. If your question's not answered today, you will receive a call from a flexible conduit expert to discuss your question in further detail. Today we'll be discussing the best conduit selections for EMI, RFI shielding, extreme temperature, and halogen-free applications. But first, let's start with information about Electri-Flex and why we're able to educate you on the best conduit for your application. Let's begin with a short video about who we are.
Electri-Flex is a family-owned business. We're third generation.
We produce flexible metal conduit and non-metallic conduits. We sell nationally, internationally.
We feel that we have the highest quality brand of conduits in the market and also the widest selection.
We don't sell to the, what we call affectionately, the DIY market. We sell only through authorized electrical wholesalers.
We pride ourselves on making the highest quality product in the industry, and we paired ourselves with the highest quality electrical distributors and contractors in the industry because of that.
We can sum up our culture in 6 letters, F-A-M-I-L-Y, family.
Our grandfather, Harold Conander, started the business in 1955. From there, my father, Wes Conander, and my uncle, Bruce Conander, became part of the business out of college.
My tenure at Electri-Flex started in 1989 and has progressed today. I'm current CEO, but we also have involvement from my sister, Blue Kelly, and my cousin JR, who is Bruce's son, is our Western Regional Manager.
The employees are treated as family members. They're fiercely loyal.
Everybody feels like they're almost an extension of the Conander family.
All you have to do is really look at the longevity of a lot of our employees in the back and up front, and our longevity is pretty impressive. We have employees that have been here a long time.
I have some employees in the factory and in the front office that have been here for 35 plus years.
And the biggest reason there is that people get it.
They're a part of something. We train all of our employees to be quality control personnel throughout our whole process. So they're all taking a hand in the quality, and they're very proud of, and no matter what part of the process of our product line that we're manufacturing, they're very proud of it.
The way the ownership treats the employees translates back to how the employees treat the product. Pride translates into quality for the employees here.
We all have the same goal in mind, which is to produce and make the best conduit in the world. And we all are passionate about that pursuit. So as a family, we pursue that together.
All the way through the whole process of accepting an order, building a product, shipping the order, following the billing processes through is all quality.
When we put the Liquidite name on a box, we expect it to be the highest quality Liquidite in the market.
Electri-Flex World Headquarters is in Roselle, Illinois, and sells exclusively through the distribution channel. We market our products through a network of manufacturers' representatives who sell only to authorized electrical wholesalers. Representatives are located across the United States. Distributors are located worldwide and are hand-selected based on high standards of commitment and performance. With so many flexible electrical conduits to choose from, it can be confusing when selecting the best product for your application. The wrong choice can leave systems vulnerable to the elements and can even cause system failure. Electro Flex specializes in flexible conduit for every application such as EMI, RFI shielding capabilities, extreme temperature environments, or halogen-free requirements. Now, let me turn the microphone over to Dan so he can introduce our shielding conduit offering to you. Dan?
Thank you, Greg. Electro-Flex offers 3 types of flexible liquid-tight conduits designed for wiring applications requiring shielding effectiveness from electromagnetic and radio frequency interference. These conduits are used to protect sensitive electronic circuits such as those used in communications, radar, and data transmission from both the ingress and egress of electromagnetic interference and radio frequency interference. These are also known as EMI, RFI emissions. Stray voltage, current, and high-frequency noise can interfere with circuits. They can interrupt performance and initiate potentially dangerous actions. Shielding reduces these potential problems, and shielded conduit provides a significant solution for engineers. The use of flexible shielded conduit is also superior to the use of shielded cable because the conduit's robust construction protects the internal conductors from physical damage. Shielding conduits also allow for quick and easy multiple conductor configurations without resorting to expensive custom cable assemblies. Shielding applications are commonly found in aerospace, communications, and many other industries where commercial off-the-shelf or COTS, C-O-T-S products are acceptable. However, there are many more applications where shielding conduits would be ideally used, such as industrial, HVAC, and utilities, especially water and wastewater because they use variable speed drives. These are also called variable frequency drives. These devices are extremely susceptible to radio frequency interference. Using shielded flexible conduit from the drive controller to the motor eliminates the potential for hazardous interference in the operation of the drive. Flexible shielded conduit is also often used in building automation applications such as dampers, blower motors, and electronic controllers. It is also used in data center wiring to keep power wiring from interfering with signal and data lines, and for similar applications in test and measurement. Flexible shielded conduit is also used in transportation and in aerospace where space is at a premium and the flexibility is an advantage, such as in trains, subways, and both military and civilian aircraft. These 3 shielding conduits are designed for high-performance shielding applications, and because of their physical property differences, they can be classified as seen here as good, better, and best solutions for EMI and RFI. Type SLA, as seen as the top one in this photo, provides the good shielding protection as compared to the other 2. Type SLA has a tin copper shielding braid located over the inner steel core, but under its protective PVC jacket. This braid offers a minimum of 90% shielding coverage. Type EMS, the next one down, offers a better shielding effectiveness than Type SLA. It has an inner core made from a fully interlocked bronze strip and does not contain a braided shield. Then an all-temperature PVC jacket is extruded over the core, resulting in a sealed, waterproof raceway when assembled with liquid-tight fittings. Finally, the Type EMCS offers the best shielding performance of these 3 and is a hybrid of both SLA and EMS because it utilizes the same bronze core and PVC jacket as EMS, but gets further screening protection from a tin copper braid as found in the SLA product. This chart shows the relative effectiveness of shielding for the 3 types of Shield Flex conduit. The baseline is the shielding capability of standard unshielded flexible conduit. In this case, Type LA, our UL listed standard conduit from Electro Flex, was used. Note that the shielding effectiveness plots vary among the three types of flexible shielded conduit and as compared to the control conduit type LA. This assists the engineer to select the conduit type with the best noise reduction for either egress or ingress at the point of maximum potential interference based on the frequency of the particular application. Now let's take a closer look at type SLA. As already mentioned, the Shield Flex type SLA consists of an inner core of strip-wound steel with a tin copper braided shield over it. This is then covered by a flexible PVC jacket. This type of flexible shielded conduit is UL listed, offers a wide temperature range, and has excellent chemical resistance. It is suitable for use in some hazardous areas as well. The conduit can be used as an equipment grounding conductor in most cases as dictated by the National Electrical Code and accepts standard metallic liquid-tight connectors. Type SLA flexible conduit has a working temperature range of minus 30 degrees C to 80 degrees C dry, 60 degrees C wet, and 70 degrees C in oil. This braided shielded conduit has a high reduction level of EMI and RFI in the lower frequency ranges. This range is from 150 kilohertz to 10 megahertz. It has a rather sharp roll-off at higher frequencies. These characteristics should be considered when choosing which shielded conduit is appropriate for your application. The braided shielded flexible conduit type SLA should be considered the good option of the good, better, best scenario. The Shield Flex type EMS does not have a braided shield, but instead it is made with an inner core of a fully interlocked bronze strip that provides the EMI RFI shielding. This flexible shielded conduit can be used over a wide temperature range, and its PVC jacket material has excellent chemical resistance. As with all of the Shield Flex style conduits, type EMS also accepts standard metallic liquid-tight connectors. The interlocked bronze strip inner core of the EMS flexible shielded conduit has a wider shielding effectiveness than the type SLA braided flexible shielded steel conduit. Its effectiveness has a more gradual roll-off until the higher frequencies are reached, approximately from 150 kilohertz to 6 megahertz. Type EMS conduit has a working temperature range of minus 55 degrees C to 105 degrees C and could be considered the better option of the good, better, best scenario. Shield Flex type EMCS has the same type of interlocked bronze inner core as type EMS, but in addition it includes the same type of tin copper braided shield as type SLA conduit. It has a very wide operating temperature range and excellent chemical compatibility because of the PVC jacket. It too is compatible with standard liquid-tight conduit connectors. Type EMCS conduit has a working temperature range of minus 55 degrees C to 105 degrees C. This flexible conduit with an interlocked bronze strip inner core and a braided shield has the best effectiveness of the three types of conduit compared in the chart above, all the way from 10 kilohertz to 18 gigahertz. Type EMCS flexible shielded conduit should be considered the best engineering option, especially for applications in which effective reduction of high-frequency interference is critical. There are applications where, in addition to EMI RFI reduction requirements, there is a need for low smoke and low flame spread materials. These applications require zero-halogen conduit jacketing, where materials such as the PVC used in the SLA, EMS, and EMCS are not permitted. These applications include confined spaces, such as tunnels and subways, and in areas where the public could be exposed to hazardous smoke and off-gassing in the event of a fire. These areas include not only subway tunnels, but also subway and railroad rolling stock, also in airplanes, elevators, and other confined spaces. These three types of flexible shielded conduit are available with a halogen-free jacketing material, polyurethane. Just add HF for halogen-free to the conduit type designations, such as HF-SLA, HF-EMS, HF-EMCS. This denotes this variation. We will be talking more about halogen-free materials later in this webinar. Using flexible shielded conduit provides a widely applicable solution to the problem of noise and interference from stray voltage and current. When you need high-performance EMI RFI shielding, these three conduit types provide the performance you need across a wide frequency range and the quality you must demand in flexible shielded conduit.
Conduits, especially flexible conduits, need to have the ability to retain their protective properties in extreme cold as well as in extremely hot environments. Conduits must retain their flexibility and their protective conditions. They cannot become brittle or fragile over the temperature range they have been designed to meet. They must be able to retain their structural integrity and protect from impact and crushing even at the lowest temperature in its operating range. Electro Flex provides a variety of conduit types that operate across both low and high temperature ranges. There are many applications where the standard temperature range of wiring and conduit are not enough to provide the level of protection required. They may require high, low, or wide temperature range conduits. Some applications require a temperature rating that will function over a very wide range of temperatures. These applications require careful attention to temperature ratings and design. Let's explore some of those applications. In refining and chemical production, numerous applications exist where conduit and conductors must meet very high temperature ratings such as jacketed reactors, boilers, and hot pipelines. Offshore platforms and oil pipelines are often exposed to both very cold and very hot weather variations, and the conduits used to hold conductors and instrument cables need to be designed to meet those variations and maintain their engineering design performance. In steel production, high temperature applications are common in foundries, forges, and rolling mills. In arc furnaces, flexible conduits with wide temperature ratings are recommended to protect both the control and temperature measurement conductors. Robotic applications and machine tool controls often require high temperature rated conduit that is also resistant to chemicals and oils. In refrigeration applications in both food and pharmaceuticals, very low temperature applications are also common. Refrigeration applications include simple refrigerators, but may also include liquid nitrogen flash freezing and other cold applications. Outside applications in many parts of the world can often reach temperatures of -40 Celsius or Fahrenheit in the winter. Sometimes these applications are consistently cold, but in other cases there can be a wide variation in temperature. Applications such as weather stations, pumping and control stations, and valve and operators can be in extreme cold for much of the year. Aerospace requires both high temperature and low temperature conduits, as do scientific applications in areas such as test and measurement platforms and wind and solar power applications. Conduit that can be used in these applications must be durable, rugged, and suitable for the service. Let's review the temperature chart for Electro Flex's line of extreme temperature conduits. To select a conduit for low temperature applications, first determine what the lowest temperature the conduit will be exposed to on a continuous basis, and also determine the lowest temperature the conduit will see as excursions. If shielding is required, our types EMS and EMCS provides a superior RFI and EMI rejection. If both low temperature operation and non-metallic conduits are required, select our type L and MP, which has an extremely low operating temperature limit. To select a flexible conduit that will operate over a wide temperature range, determine the operating range and excursion of temperatures that the conduit will be exposed to. Determine if the conduit requires zero-halogen construction, low flammability, or high-performance shielding. Then you can select the flexible conduit design and type that most clearly fits your engineering application. Once the temperature requirements have been determined, the next step is to analyze the conduit characteristics to make sure the correct conduit is selected for the application. For example, if a UL or CSA certification is required, type ATLA may be the best choice. Or if a halogen-free conduit is required, type ATX would be the best choice. Type ATLA offers UL temperature ranges of negative 55 degrees Celsius through 105 degrees Celsius. It's UL listed, CSA certified, RoHS and WE compliant, and CE compliant. Its core is made from hot-dipped galvanized steel, and its jacketing is a flexible PVC. Some key benefits of Type ATL include self-extinguishing characteristics, sunlight or UV resistant, and it is listed for direct burial. Type AT offers temperatures of negative 55 degrees through 105 degrees Celsius, intermittent to 120 degrees Celsius. It's RoHS and CE compliant. The core is made of corrosion-resistant plated steel, and the jacket is a flexible PVC. Type AT is sunlight or UV resistant and offers a small bend radius. Type ATX offers the largest temperature range at negative 60 degrees Celsius through 150 degrees Celsius, intermitting to 165 degrees Celsius. It is RoHS and CE compliant with a corrosion-resistant plated steel core and a flexible thermoplastic rubber jacketing. Type ATX benefit include halogen-free, UV stabilized, flame rating of UL 94-B, and offers a small bend radius. If a nonmetallic conduit is required for an application, types LNMP and NMHT would provide the best conduits for extreme temperature environments. Type LNMP offers temperatures of negative 55 degrees Celsius through 105 degrees Celsius, is UL listed, CSA certified, and is RoHS and WE compliant. It is made of flexible PVC with a nylon reinforcing braid and is Type A construction. Type LNMP works well in continuous flexing applications such as robotics. It has self-extinguishing characteristics and is sunlight or UV resistant. Type NMHT offers temperatures of negative 20 degrees Celsius through 105 degrees Celsius, is UL listed, CSA certified, and is RoHS and WE compliant. Type NM is helically wound integral Type B construction. It contains a spiral of rigid PVC reinforcement embedded within the PVC wall. It is sunlight or UV resistant, listed for direct burial, and is self-extinguishing. Shielded types EMS and EMCS offer similar characteristics. They both offer temperature ranges of negative 55 degrees Celsius through 105 degrees Celsius, are CE compliant as well as RoHS and WE compliant. Both conduits have a flexible PVC jacketing over a bronze core, but type EMCS also has a shielding tinned copper braid, making it the best selection for shielding protection. Both conduits are self-extinguishing and provide sunlight or UV resistance. Electro Flex company provides an extremely wide variety of flexible conduit designs that satisfies the vast majority of application, regardless of temperature range or materials of construction and design.
Thanks once again, Greg. Our next and final look into specific types of liquid-tight conduit deals with halogen-free. Why select a halogen-free conduit? To start, many applications require materials with flame retardancy, low flame spread, and limited smoke and toxic fume release characteristics. These applications include confined spaces, tunnels, transit vehicles, elevators, and adherence to some building codes and other locations where low smoke and low flame spread are requirements for the materials used. In general, the market for zero-halogen conduit is where the conduit, potential ignition sources, and people are all together in closed spaces. These also include airplanes, trains, trams, buses, subways, underground structures, recreational vehicles, shipboard applications, and tunnels. Wire, cable, and conduit insulation and jackets can contain halogens, such as in PVC. Under fire conditions, they can release unwanted smoke and toxic fumes. These fumes are often referred to as halogens and can include hydrogen chloride gas, hydrogen fluoride gas, hydrogen bromide gas, and other deadly combustion products. Because of the potential for fire-related incidents, many manufacturers and agencies require the use of zero-halogen materials in these environments. Electro Flex Company provides a large selection of zero-halogen flexible conduit jackets to reduce the incidence of flame, smoke spread, and the presence of dangerous fumes and vapors. Electro Flex Company uses non-halogen materials of construction on its line of halogen-free conduits. Shown here are types CEA, ACEA, ZHLA, HFSLA, HFEMS, and HFEMCS. These are all made with a specially formulated thermoplastic polyurethane jacketing material instead of the normal PVC. Our Corlock type CLFR is made of a specially compounded, homogeneous, flame-retarded, halogen-free nylon 6 material. Both of these specially formulated polyurethane and nylon 6 materials provide excellent low smoke, flame retardation, and toxicity generation characteristics. Acidic gases such as hydrogen chloride, hydrogen fluoride, and hydrogen bromide are almost completely eliminated as products of combustion in these conduit jackets. The chart shown here represents the results of third-party testing on our specially formulated polyurethane compound that Electro Flex uses as a flexible jacketing material for the following types of liquid-tight conduit. These are types CEA, ACEA, and ZHLA, which I will provide more details on shortly. This material is also used as an alternate jacket for our Shield Flex series, which we've already discussed. In addition to the common UL tests and ratings, most importantly, the polyurethane material was tested to ASTM E162 for flame spread. This is an index for flame travel over a set amount of time, and the specimen cannot produce any flaming drips. ASTM E662 is for smoke generation in both the flaming and non-flaming modes. This measures smoke density over both the 1.5 and 4 minute period of time. Bombardier SMP 800C is a measurement for minimum trace amounts of various toxic gases. In all cases, the results were far below the minimum industrial acceptable thresholds. This chart depicts the same testing program, but as applied to our type CLFR corrugated nonmetallic tubing. This is made from a specially compounded nylon polyamide 6 flame retardant material. Once again, the results are far below minimum requirements. Electro Flex manufactures 3 specific types of zero-halogen jacketed metallic flexible conduit to cover a wide range of applications. Type ZHLA is manufactured from 3/8 to 4-inch trade size, Type CEA up to 6-inch trade size, and Type ACEA up to 4-inch trade size. Type CEA is made with a polyurethane jacket and a corrosion-resistant plated steel core. It has a working temperature range from -40 degrees to 80 degrees C. Type CEA is not UL listed, but it is RoHS and WE compliant. Type ACEA is very similar to CEA with the exception that the core is constructed of an aluminum alloy strip. It is much lighter in weight than Type CEA due to its aluminum core. Type ACEA also has a working temperature range from -40 to 80 degrees C and is also not UL listed but is compliant with RoHS and WE. Type ZHLA is also made with the same polyurethane jacketing, but its core is made of a hot-dip galvanized steel. It offers a working temperature range of -40 degrees C to 80 C in air, 60 degrees C when wet, and 70 degrees C in oil. Type ZHLA is UL listed, CSA certified, RoHS, and WE compliant. Applications for Type CEA could include mass transit vehicles, specifically for wiring harnesses within and under passenger train cars. when weight is also a criteria in addition to flame resistance and limited smoke and smolder characteristics, type ACEA can be used, as it is lightweight, approximately half the weight of its steel counterpart, type CEA. Type ZHLA is rated for installations under raised floors and data processing areas in clean rooms. Type ZHLA is suitable for use in electric signs and outline lighting over 1,000 volts and used in elevators and hoistways. In addition, Electri-Flex Company's type ZHLA flexible conduit may be used in some hazardous classified locations. It is UL listed and approved for installations in Class 1 Division 2, Class 2 Divisions 1 and 2, and Class 3 Divisions 1 and 2 hazardous areas. As already mentioned, there is an option to provide a halogen-free jacketed liquidite shielding conduit combination. Here we take the good, better, best shielding constructions and extrude a polyurethane jacket over them. A good example of where these have an advantage over standard liquidite conduits may be where data transmission circuits require shielding protection and are located in a confined space, such as a data center plenum floor. Type CLFR is part of the core lock system from Electri-Flex and is suitable for use within public transit and passenger rail vehicles. As a previous slide pointed out, it is a corrugated flexible tubing made from a flame-retardant nylon 6 compound offering low flame spread, low smoke, and limited toxic characteristics. A slit version of this tubing is being used as protection for wiring harnesses in aircraft. In conclusion, Electri-Flex Company's Zero-Halogen jacketed liquidite flexible conduits are designed to protect in the event of a fire for a wide range of applications such as transit vehicles, underground utilities, subways, tunnels, or direct burial. These conduit types will give you the choice you need to select the right low smoke, low flame spread conduit for your enclosed space or hazardous application.
Okay, Greg and Daniel, thank you so much for that great presentation. Okay, let's get on to those questions. Our first question here looks like it's for Dan. Why would I need a UL listed conduit if you offer a non-UL?
I get this question asked of me all the time. A UL listed conduit is generally required for installations in the field where it must meet certain code requirements such as the NEC. Many inspectors insist on this. There are industries, however, not covered by the code, such as mining, transit, and power utilities, plus some machinery builders. Although these industries set up their own requirements, they may allow non-UL listed products to be used.
Dan, thank you very much for that answer, and it looks like this next question is for Greg. What is meant when referring to intermitting working temperatures?
When we refer to intermitting working temperatures, we're talking about those temperatures that recur in scattered and irregular or unpredictable intervals.
Okay, Greg, thank you very much for that answer, and it looks like, Dan, this one's for you. You mentioned a 150 degree C rating for ATX conduit. Is there a fitting with the same rating?
Yes. We recommend the use of a special liquidite steel connector that includes an insulated throat and gland ring made from a polymer rated for 150 degrees C. On our website, we reference a specific fitting series available from Thomas & Betts, suitable for type ATX.
And thank you very much, Dan, for that answer. Greg, it's going to be back over to you for this next one. What is the average lead time for a product?
Products that are ordered in our standard package links are available for immediate shipping, and we generally ship those out 2 to 3 days from receipt of a purchase order. Specials usually take 2 to 3 weeks from the receipt of your purchase order for us to get those out the door.
And thanks very much, Greg. Looks like we'll stay with you for this next question. Do the shielding conduits require a special connector or fitting?
A benefit to our shielding conduit offering is that no special connector is required. Any UL-listed liquid-type flexible conduit connector works with our product.
And Greg, thank you very much for that answer. Okay, Dan, this one's for you. Do the shielding conduits require special prep to accept the fittings allowing for proper grounding?
Another great question. No, our Shield-Flex series requires no prep other than a good, clean, square cut. There is no need to remove any of the jacket like you might for shielded cables. As Greg just mentioned, a standard Liquid-Tight metal connector is used, and they contain a grounding ferrule which screws directly into the interior of the conduit, making secure contact to the inner core. In the case where a tin copper braid is also part of the conduit construction, the braid itself is in direct contact with that metal core throughout the entire length, thus creating a direct path from shield to ground through the connector assembly.
And thanks, Dan, for that answer. Here's another question for you, Dan. Are there conduits available for temperatures above 150 C?
150 degrees C is the highest temperature rating for conduits we provide that incorporate a plastic material. We do also make non-jacketed all-metal flexible conduits, so there's virtually no temperature limit. The contained conductor insulation would be the only limiting factor.
Okay, Dan, thank you very much. It looks like we have time for another question. And Dan, again, this one is for you. How do these products mentioned translate into global markets? And do you have CE declarations, for example?
Yes, all of the products mentioned here today, along with the vast majority of our entire product line, have been tested to the EN IEC 61386 International Standard and bear the CE mark.
All right, gentlemen, it looks like we're just about out of time, so we're going to have to wrap things up right there. Dan Coolidge and Greg Raptors, thanks so much for taking some time with all of us today. Again, thanks for taking time to attend this webinar event. Take care and have yourselves a great day.